Hi YouTube, Tim Unkert here. In this video, we're going to plot some data on Desmos. We're going to create a scatter plot based on sample student data. And I got the sample student data. I actually went to Gemini and I said, hey, give me some student data on 20 high school students. Give it to me in their weight in pounds and height in inches. So we're going to create a scatter plot with this and also create a line of best fit. So you'll see how to do that on Desmos. So I've got this table here. I've got each student numbered 1 through 20, and I've got their weight and their height. Okay, and I'm going to use height as the independent variable. That's going to be the x-axis, and weight as the dependent variable. Okay, so what I'm going to do, let's go and open up Desmos. Okay, so once I have Desmos open, what I'm going to do is click this plus and create a table here. And again, my x values are going to be my height in inches, and the y value is going to be the weight in pounds. So I'm going to come on back once I fill out the table, and we'll go from there into creating the line of best fit. Okay, so I've entered in the data here, and you notice you don't see anything here. That's because we have to zoom out. So let's do that. Let's zoom out. And now we notice we have the data here. Now, interestingly, so Google Gemini did create this. So if we look at this, this is pretty well in a straight line. It maybe is a little bit unrealistic, but let's go with it. So let's go down to another cell here, and let's create our line of best fit. And to do that, we're going to type Y, and then we're going to do an underscore to get the sub 1, and then we're going to do shift and the key above the tab, and that's going to give me this that little curl there that you see right here. Hopefully you can see that. That means approximately. And then we'll do MX and then do underscore to get sub 1. Okay, use the arrow to get out of that plus B. Okay, and now that gives me the line of best fit. And what I can do is I can hold this and change the color. So let's do it in red so we can see it a little bit better. There, and let's see if we can zoom in a little bit, and there we go. We got it going through most of our points. Now notice most of the points are right on the line of best fit. We have a couple that are out. Maybe we can prompt the AI a little bit to give us more variation. We notice it gives us some things here. So the correlation coefficient is 0.9932. That's a very strong correlation. And get our equation here. You see it gives us the M value of 4.96596 and the B value of negative 187.72766. So if we go back here, what is the line of best fit? We're going to say Y equals, and we've got 4.96596. 4.96596, and then the B value is minus 187.72766. So we'll have minus 187. Let's just check that again, 72766. 72766. Okay, so that's our line of best fit. All right, so now it says use the line of best fit to estimate. Oh, we've got to have X here. Almost forgot that. That's important. So our line of best fit is Y equals 4.96596X minus 187.72766. So it says use the line of best fit. Let me thicken this up a little bit. Use the line of best fit to estimate the weight of someone who is 174, or who is 74 inches tall. My apologies, who is 74 inches tall. So remember, Y is like our weight, and then X is our height. So we're going to say our weight. And since we're estimating, let's just do 4.96, let's round it to 5. So we'll do 5 times 74 and we're going to subtract 187.7. And let's see what that equals in Desmos. So let's go back here. So y, well, actually, let's just do the right-hand side. So we'll do 5 times 74 minus 187.7. And we get 182.3 pounds. So 182.3 pounds. Fix that. That's pounds. All right, so what is the R value given by Desmos? It's 0.9932. So 0.9932. Now, some people define their ranges differently, but generally a very strong association is between 0.8 and 1.0, with 1.0 being like a perfect association. So let's just say very strong association. What might be affecting the association? Well, if we look here, there's nothing really that's that far out. So I'm going to say nothing really. There's no real outliers. So nothing really, no real outliers. Now you'd want to test for outliers, and we'll get into that later, but there's no real outliers from just looking at it. What are the points that are best fit by the line of best fit? So any of these points on the line, I would say any point on the line. Okay, what are the points that are worst fit by the line of best fit? Well, maybe this point here, this point here. Yeah, there's 2 points that are not really on the line. So we'll say the 2 points that are not on the line, although they're pretty close. So yeah, the 2 points that are not on the line are the ones that are not, or I wouldn't say worst fit, but are a little bit further away from the line of best fit. Hopefully you enjoyed this example and enjoyed me going through and showing you how you might use AI to generate data and the caveat of that. Yeah, maybe I'll do another one where I prompt it to give me a little bit weaker of an association and see how it does. Anyways, if you enjoyed this video, please give it a like and subscribe to the channel. It really helps a lot. Thank you.